In this lecture, okay, we will discuss the set interface, okay, or the Java set interface. Okay, so what is a set or what is a set? It is a collection, okay, collection that does not allow, okay, duplicate elements. Okay, now set, okay, makes it a great choice when you want to ensure uniqueness in your data. Now, what are the key characteristics of a set? Okay, it is unordered. Okay, it is unordered. Okay, meaning there's no guarantee of the order in which elements are stored. Okay, and it does not allow duplicate. Does not allow duplicates. Okay, wherein it ensures that each element in the collection is unique. Okay. Now, the set interface is part of the Java Collections framework and is located in your java.util package. Now, what are the some common implementation of the set interface? Okay, we have the hash set, okay, a fast, and unordered implementation. Okay, we also have your link hash set, which maintains insertion order. Okay. Then we have your tree set. Okay, which maintains uh, element in ordered or in sorted order. Okay. Now we'll uh, check one by one or each uh, implementations of your set interface. Okay. Let's check first the hash set. Okay. Hash set. Our hash set. Okay. Now, our hash set is, or the hash set uses a hash table. Okay. Uses a hash table. Okay, for storage. Now, making it very fast for operations like adding or checking of elements. However, it does not guarantee any specific order of elements. Okay. A typical use case of this one is storing unique IDs. Then next, you have your link hash set. Right? It is similar to your hash set, but again, it maintains the order in which elements are added. Okay? Um, it's slightly slower than your hash set due to the extra overhead of maintaining order. And the common use case is maintaining a unique collection while preserving insertion orders. Then we have your tree set. Okay, it maintains the elements in sorted order. Okay, making it useful for scenarios that require sorted data. Okay, it implements your tree sets implements the so-called navigable set. Okay, navigable set interface. Okay, which allows advanced navigation like finding elements closest to a given value. Now, an example use case of this one is performing range-based queries on unique data. Okay. Now, Before I'll provide you an example of the common sets or the common implementations of the sets, now let's go over with some basic operations that you can perform on a set. Again, uh, you can add an element using add method. You can remove an element using the remove method. And again, you can check if an element exists. Okay, you can check if an element exists um, by using the contains method. Okay, now let's go to the demo of your uh, hash set, link set, and your tree sets. Okay, so again, we will have to import java util hash set, or again, you may just opt to do the util asterisk. Okay, import java util link hash set, then import java util tree set. Okay, then let me just create the class name, public class. Um, we'll just have this as set demo. Okay, then public static void main string args. Okay. In this one, we will try to create our hash set. Okay, so this is a marker hash set. Now, to create your hash set, we will have our sample. We will create a hash set of integers. So hash set, just like what you have done in your list. So hash set. For this one, we'll just use the hash set keyword, then our type, which is an integer, then our hash set name. So we'll just have this as hash set. Okay, then new hash set for our interface. Now we will add elements to the hash set. So how do we do that one? Hash set dot add again. Okay, so let me just add 10. Okay, hash set dot add 20. Then hash set dot add 30. Okay, then uh, we now try to display our hash set. Okay, so system dot out dot print line our hash set is class hash set. Okay, so save. Then let me save this as set demo. The set demo. Then I'll choose the save as type as Java. Okay, so here in so Java So we will compile set demo.java, then java set demo. Okay, so we have here our hash set 20, 10, and 30. Now, the order of elements, again, in Hashset is not guaranteed because it uses the hash table for storing elements. Okay, a hash table relies on the hash codes of the elements, which determine the position of your element or of each element in the underlying data structure. Now, in this example, why does 20 comes first, even though in our program it was added uh, on after 10 or it was added second. Okay. Now, again, hash set, okay, doesn't guarantee, okay, order of storing elements. Now, when you add elements again to a hash set, their hash codes are computed and the elements are placed in the hash table based on their hash codes. Now, the iteration order of the hash set depends on how your hash codes map or on how the hash code maps to the internal structure of the hash table. Now, this is why the order in your hash set can appear random or inconsistent across, okay, different runs or different Java versions. Now, when the program adds elements to your hash set, the um, following could possibly happen. So let's try to uh, basically let's try to just perform some hash code calculation. Now, in but before that one, let me just add, okay, just to prove that it doesn't. Okay, the second key characteristics of hash set wherein it does not allow duplicate. So let me just try to add again hash set that add 30. Okay, then let me uh, update the hash set. Let me print it again. So save. So there you have it. Okay, it does not add your uh, or it does not add this line or this 30 as a new element in your hash set because again hash set does not or set does not support any duplicates. Now going back to the hash code calculation, okay, each element, okay, your 20, 10 or the 20, 10, 20, 30 has its hash code calculated using its or using the hash code method, okay, using our hash code method. Now for uh, integer, the hash code is simply the integer value itself, okay? But for strings, there are certain or Java generates the hash code through this hash code method, okay? So the hash code of 10, since we mentioned that the that for integer the hash code is simply the integer value, okay? So the hash code for 10 is 10, okay? For 20 is 20, okay? Then for 30 is 30, okay? Now, but how come that our or the appearance is still 20, 10, 30? Now, it will now be depending on the hash as we enter our hash table buckets. Now, these hash codes are mapped to the buckets in the hash table based on their hash code modulo the table size. Okay. So, for example, if the hash table size is 16, okay, the bucket index for each element will be calculated as this bucket index is equals to hash code modulo table size. Okay. Now let's try to perform this one. 10 modulo 16 will be 10. Okay. So 20 modulo 16 is 4. Now 30 modulo 16 is 14. Okay. So if we will to store it in a bucket, okay. So we have so we will try to store that in our bucket. So we'll have 4, okay, to be stored in our bucket 4, okay, or sorry, the 20 will be stored in bucket 4, and 10 will be stored in bucket 10, and 30 is stored in bucket 14. So if we want to depict our bucket, so we have your uh, bucket, for example. So you have your 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Since because we have table size of 16. So if we will to change that one, okay, so let me just depict it with that. 3, 4, 5, 6, 7, 8, 2, 3, 4, 5, 6, 7, 8. So now, then your 10 modulo 16 is 10, so it will be stored in bucket 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it will be stored in your bucket 10. Now we have 20 modulo 16, which is bucket index 4. So 1, 2, 3, 4. So it will be stored here. So 20. We have your 30 modulo 16 at 14. So 16, 15, 14. So 30. Again, if you will to check, 20, 10, and 30. 20, 10, and 30. That is their sequence. Now, um, iteration order in your hash set will, or when you iterate over your hash set, it retrieves elements based on the order of buckets in your hash table. Okay, as you have or as I have presented to you. Okay, not the order in which elements were added. Okay, again, in this case, we have 20 coming first. Okay, before your bucket uh, 10 or for your bucket 10 and or 30. Okay, so um, so again, uh, why would this happen specifically? Number one, the order depends on number one, um, hashing algorithm. Okay, number two, your internal bucket structure of the hash table, and number three, if you were to run the same program on different JVM implementation or with a larger or smaller hash table size, the order could change. Okay, so that's your hash set. Okay, I hope you understand on how hash set works. Now let's try to create our link hash set. Okay, so link hash set. Okay, we now try to create our link hash set. So we'll just let me just copy this one. And copy link hash set. Okay, and then I'll just rename this to link hash set. Okay, then we add elements to our hash set. Okay, so again, how do we add? Okay, link hash set dot add. Okay, which is we'll try to have um, fruits. Okay, for this example. So again, for this one, let me just change this to string since we will be storing string. So string. Okay, apple. You just copy this one. Then we just change this to banana and to orange, maybe orange. Orange. Okay. Now let me display. So display our link hash set. So link. So save. Then compile. Then run. Okay. So you can see there apple, banana, orange. Now let me do the same. Let me just add. Okay. The duplicate. For example, uh, link hash set um, banana. Okay, so then we'll try to print. So have updated link hash set. So save. Then we compile. Uh, link hash set. Sorry, link hash set dot add. Okay, save. Run. Okay. Again, so you can see um, there is no duplicate. Okay, there's no duplicate. Banana herein was not added because it was not part of the or because it is already part of our link asset. So we'll just try to add example cherry. Okay, save. So as you can see, we can add new fruits. Okay, if it is not yet available in our current link asset. Okay, so again, to reiterate, we do not duplicate or set doesn't allow duplication. Okay, so let's check the other. Now, before I move to this one, as you can see, it the link or the link has set maintains our insertion order. Okay, so we can check as we entered apple as our first element, it was entered first. Okay, banana, banana, orange, orange. Then the moment that we added cherry, it was added at the fourth. as our fourth element. Okay, unlike uh, if we will to implement that on a hash set, okay, again it will depend on their hash code as they entered our hash table. Okay, now let's have your tree set. Okay, for tree set, again, can just copy this one, copy. Okay. For this time, we will be using integer. Okay, but you can still use in if you want this one. You can still use string if you want. Okay, but we will just demo it in uh, integer. Okay, so tree set. Now we add okay our elements. So tree set that add. Okay, what we add is 50. For example, let me just copy this one. We'll have 10. Right? We'll have 20. Then we have uh, we have here 70 and we have here 20. Okay. Now let me just print or we just print our tree set. Okay. Tree set, then save, compile, then so we can check. Okay. Our tree set maintains elements in sorted order. So in this case, we entered first 50, then we entered 10, we entered 70, or we add 70, we add 20. But when we displayed them, it was sorted already, okay? Because that's the principle or that's the characteristic of your tree set. It will sort your elements in order. So 10, which is now first in our set, we have 10, 20, even though it was added last. Okay, so 50, 70. Now let's try to add another one. Okay, so let me just copy this one. Okay, then let me add maybe 25. Okay, then copy. Let's print the updated preset. Save. Okay, so you can see the newly added element was added our as our third. Okay, because it follows the order, the proper ordering, which is in an ascending order. Okay, if it is string, it will be sorted in an alphabetical order. Okay, now uh, for our let's just try to check for specific elements. So how do we do that one? So let me just copy this one. Oh, no, okay. Okay. See you on the part two of this demonstration. Thank you.